Okay, so this lesson is going to be finishing off the chain rule, and we'll do some questions with u substitution as well. So what we are differentiating is x squared times the square root of 1 minus x squared, and we're differentiating everything with respect to x. So the first thing I want to do is let's rewrite this, and let's get rid of our radical sign. So what we are going to differentiate is x squared times 1 minus x squared to the power of 1 half. And we're going to differentiate that with respect to x. So we're going to take the derivative. Which rule would I start with if you're told to differentiate this? Like this is going to be a chain law, chain rule, but this times this, what would it have to be? It would be product law question. Okay, so for product law, let's call this u and this v. And remember that when we are differentiating the product law, what we are getting is u v prime plus v u prime. Okay, so we're differentiating, so the derivative, I'm going to write it as dy dx is equal to, so u and then v prime, so u is x squared, and v prime, taking the derivative of this function, it's going to be chain rule. So bring that 1 half in front, 1 minus x squared, 1 half minus 1 is negative 1 half, and then take the derivative of the inner function. The derivative of the inner function would be this negative x squared. If you bring that 2 in front, it would be negative 2x. And then 2 over 2 will cancel. So there's my u v prime plus v. So v was 1 minus x squared to the 1 half. So u v prime plus v, and then u prime would be 2x. So let's clean this up. So dy over dx is equal to, okay, so I've got x squared times negative x. That would give me negative x cubed. And then I have that 1 minus x squared to the negative 1 half plus, I'm going to bring that 2x in front, and 1 minus x squared to the 1 half. From here, I've got two terms. So look at these two terms and say, what can you factor out of here? So between an x cubed and an x, Sarah, what would I factor from that? Yep, I could factor out an x. That's right. Then I'd factor out 1 minus x squared to the negative 1 half. Okay. So I took out an x. I factored out a 1 minus x squared to the negative 1 half. What I am left with is negative x squared. This would cancel. Plus 2. The x's would cancel. What is what's 1 half minus minus 1 half? That's 1. Yeah, because it's a half plus a half, which is going to be 1. So that would be 1 minus x squared. I don't need to put that to the power of 1, but I would have this. And then chances are we'll be able to clean up this bracket, or we will be able to. So what I would have in this bracket is I've got negative x squared, and then I've got plus 2 minus 2x squared. So we'll clean that up. So I've got an x. Are you okay if I take this and write it in my denominator to make it positive? So I'm going to write that in my denominator, and I'm also going to write it as a radical. So that would be the square root of 1 minus x squared. And then this would be minus 3x squared plus 2. And that would be the derivative. Okay. Okay, let's do this guy. Now, this one could be done in two different ways. So we could apply the chain rule, bring the 4, write our inner function to the power of 3, multiply by the derivative of the inner function. How would we take the derivative of the inner function? It'd be a quotient law, low d high minus high d low, draw the line and square below. But what I'm going to do is let's do this as u substitution, okay? So let u equal, let's u equal my inner function. So 3x minus 1 over x squared plus 3. Later on for studying, what I would do is this would be a good one to redo without doing u substitution, right? Do the chain rule, and then you're going to be multiplying it by the derivative of the inside, which is the quotient rule. But let's do u substitution for this one. So let u equal my inner function. So that means that I won't call it h of x. I'll just call it for now y. Y is equal to u to the power of 4. Let's take the derivative of this function. So taking the derivative of that first function, Julie, how would I write it? D what over d what? So we're taking the derivative of u over, yes, with respect to, there's x's within the function, with respect to x. Okay, so this would be quotient law. So this is a quotient law question you'd get on your test tomorrow. So let's figure out what the quotient law for this would be. So it's low d high. So low is x squared plus 3. And what's the derivative of the upper function? 3. Are you okay if I write it like this in front? So low d high minus high would be this guy. D low. Maya, what's the derivative of my lower function? Yes, and again, I'm just going to put it in front. So what I have is low d high minus high d low. Draw the line and square below. Okay, let's clean up this. Du over dx is equal to, so 3x squared minus 6x squared is minus 3x squared plus 2x plus 9 all over x squared plus 3 squared. So that's my du dx. Okay, let's take the derivative of this function. Emily, what would you write for this one? First, d what over d what? yeah, derivative of y with respect to u is equal to, yes. Okay, so now the derivative of these two functions, so dy over dx, remember, if I multiply this function, du over dx, and if I multiply that by this function, dy over du, what will happen? Du over du will cancel, and I'm left with dy over dx. So the derivative is always going to be, when you're doing u substitution, the two functions multiplied together. So it's going to be negative 3x squared plus 2x plus 9 all over x squared plus 3 squared. And then this is going to be multiplied by 4u3. U is, what was u? U is my inner function. So let's rewrite this. U is my inner function. So dy dx. And you know what I'll actually do? Let's put that in front. Let's put the 4u3 in front. So 4 times u now. So u, remember, was my inner function. So u was 3x minus 1 over x squared plus 3. And then that is multiplied. So there's my 4u cubed, and then it's multiplied by this function here. So this guy would be negative 3x squared plus 2x plus 9 all over x squared plus 3 squared. Now, it looks like it's done, but there's actually something that can be cleaned up in here, and it's with the denominators. So I want you to look at what's happening in the denominators. I've got x squared plus 3 squared, and here I have x squared plus 3. Do you know what this would actually be to the power of? Yes, because of this 3. This 3 applies to this top binomial and this bottom binomial. So I could combine this and this together to give me x squared plus 3 to what? 5. Yes, because that 3 would apply up here and below. So what my final answer would be, dy over dx, I have a 4. Then I've got this binomial cubed, which would be 3x minus 1 cubed. I have this negative 3x squared plus 2x plus 9 all over. This binomial is also cubed. And if I add the exponents, I'm going to get x squared plus 3 to the 5. Okay, so quite complex. We're going to do one more complex one, which would be like a standard of excellence, and we're going to use u substitution. Okay, so this last one, let's rewrite this. Y is equal to, take everything out of its radical signs, or out of its radical. So x plus x squared plus 1 to the 1/2, and that's all to the power of 1/2. You could do the chain rule right from the beginning. So I could bring this 1/2 in front, keep the inside function to power of negative 1/2, then take the derivative of the inside, but the derivative of the inside is going to have another chain rule happening. Or I could be like, I want to kind of simplify this by doing u substitution. So what I'm going to do is I'm going to let this inner function be equal to u. So let u equal x plus x squared plus 1 to the 1/2. Okay, so if that's what u is, write down what y would then be equal to. So y is equal to u to the 1/2. So I'm just taking this whole thing and I'm letting that be equal to u. Okay, let's differentiate this function. So derivative of u with respect to x is equal to the derivative of x is 1. The derivative of this function would be chain rule. So 1/2, inner function stays the same. Subtract 1 to give me negative 1/2. The derivative of the inside function is 2x. 2 over 2 will cancel. So I'm going to have 1 plus, I've got an x remaining, and let's bring that x squared minus 1 to my denominator, and let's write it back as a radical. So make it positive by bringing it to the denominator, and then we'll write that as a radical. Now, we know that we're going to be multiplying this function by the derivative of this. So what I want to do before I do that is let's just get common denominators here. Let's write this as one fraction before we take the derivative of my other function. So if I have this denominator has a square root of x squared plus 1, let's get common denominators by multiplying this denominator by square root of x squared plus 1 and x squared plus 1. So my du over dx is equal to square root of x squared plus 1 plus x all over square root of x squared plus 1. Okay, so I have that. Derivative of this one will be quick. Owen, tell me how I'd write the derivative of y here. But first, d what? Yep, equals. Okay. So my overall derivative is this function multiplied by this function. So dy dx is going to be equal to, oh, and let's just rewrite this one with our 1/2. Let's just bring our u down here to the 1/2. Okay, so it's going to be this function. Now our u is this crazy thing. So let's write that guy to the power of 1/2. So x plus that's to the 1/2. Okay, so it was this function times this function. So my denominator, I'm going to multiply it by, that will be my denominator. And my numerator, it's going to be 1 times this numerator. So it'll just be this numerator, right? So it will be okay, so it'll be this. And then there's something that I didn't see this initially, but there is actually something in here that cleans up. And what I want you to look at is I want you to look at this bracket and this. Do you notice anything? So this numerator is x plus square root of x squared plus 1. And down here, this is x plus, this is really square root of x squared plus 1. Do you guys see that? So again, this bracket and this bracket, they're actually the same. So what can we do to clean up these two brackets? Do you see how they're the same? Right now, this isn't written as a radical. So if you want, like this guy right here, if I want that as a radical, so you might be able to see it, that's really this. So look at this top. I've got x plus square root of x squared plus 1. I've got x plus square root of x squared plus 1. This is really to the power of 1, and this is to the power of 1/2. Can I combine these? Yes. I just subtract the exponents. So 1 minus 1/2, what would that give me? Yes, it would give me this bracket to the power of 1/2. So dy over dx is equal to square root of x squared plus 1 plus x to the 1/2 over what my denominator would be. It would have a 2, and then it would have this would be left there, x squared plus 1. And then this numerator, I could just clean this 1/2 up by writing it like this. So really hard to see. Like if you got to this, that would be good. But then again, that actually would clean up as well. This would be like a standard of excellence question. Okay, let's end with different style of question, and then I'll show you an AP question from an old AP exam. So what this is saying, it says find dy dx when x is equal to 1. So what this is saying is we know that dy dx is the derivative. So what it wants me to find is it wants me to find the derivative when, and they want when x is equal to 1. So dy dx is the derivative. Find the derivative when x is equal to 1. So they've given me two different functions, and I could take the derivative of each function. So y is equal to u squared plus 4. Let's take the derivative of that function. So dy with respect to u is equal to 2u. Then I could take the derivative of this function. So I'm taking the derivative of u with respect to x, and the derivative of that function would be, according to the power rule, 12x to the 3. They want me to find dy dx. If I multiply these two functions together, my du's will cancel, and I'll be left with dy dx. So let's multiply those two functions together. So we're going to multiply 2u times 12x to the 3. dy over dx, the derivative, it's going to be equal to 24 u x to the 3. Now they want me to, this is the derivative, they want me to find the derivative when x is equal to 1. So I'm going to be putting a 1 in for x, but first I have to get rid of u. What was u equal to according to what they initially gave me? We're going to take u out, and what are you going to put in for u? 3x to the power 4. So I've got 24. U is 3x to the 4 times x to the 3. Okay, so that's my dy dx. So dy over dx is equal to, what's 24 times 3? 72 x to the 7. They want me to find the derivative when x is equal to 1. So now I found the derivative, and they'll often say when x is 1, because we could easily plug in a 1 or a negative 1. So now we're going to put in a 1. And our answer is 72. Yes. Say that one more time. Oh, no. Normally the notation would be bar here, and then this. Yeah. So let's do another question like this style, which would be this guy. So what they want is they want us to find the derivative when x is 1. So say to yourself, they gave me y, I could take the derivative of this. They gave me u, I could take the derivative of this. So let's take the derivative of each of our functions. So Akil, read me what you want me to write for my first function. Yeah, dy du equals plus what, sorry? 1. Okay, there's my first function. Shayla, what do you want me to write for my second function? Du over dx is equal to 3. Okay, so what they want me to do from here is they want me to find d. And I know that dy dx is by this function, by this function. Now I'm actually going to write the 3 in front. And I'm going to multiply that by 7u6 plus 3u squared plus 1. Okay, we could distribute in our 3 if we want. (21) u6 plus 9u plus 1. Now, there's two ways you could, because we want dy dx, so we got our derivative. Now they want us to solve when x is equal to 1. So there's two ways I could do this. I could take each of these u's out and put in 3x minus 2, or I actually am able to figure out the value of u when x is equal to 1. Right? Does that make sense? Like I could do it in one of two ways. I could take u's out, put in 3x minus 2, but then I'm just going to be plugging in 1 for x. So if I want, I could find the value of u. So u is equal to 3x minus 2. I could, again, put 3x minus 2 here to the power 6, 3x minus 2 here. But then I'm just going to be plugging in when x is 1. So what is u going to be equal to when x is 1? 3 times 1 minus 2. U, when x is 1, will be equal to 1. And then now we'll be able to get the answer a lot faster. Because if u is 1, I'm going to have 21 times 1 to the 6 plus 9 times 1 plus 1. So, yes, should be a 3 and a 3. Sorry, this should be a 1, and this was a 3. Thank you. It won't change our answer because they chose 1, and they chose that on purpose. So what's our final answer going to be? 33. Okay, let's do this one, which is a really good exam style question. So you're going to see a couple of these on your derivatives exam. And then after this question, we'll do our last question, which is from your AP exam, one of the questions. Okay, so this you need to recognize from 30-1 is a composite function. Remember that f is our outer function and g would be my inner function. So what this really is, this is going to be f of g of 3. And then what they want me to do is they want me to take the derivative of that. So again, recognize that this is a composite function from 30-1. It's f of g of 3 and the derivative of that. Now we did this yesterday. Do you remember how to write the derivative? This is the chain rule, essentially. So f of g of 3 is, remember, it's your outer function. It's the derivative of your outer function. Inner function stays the same, times the derivative of the inner function. So what that would be, the outer function is f. So it's the derivative of the outer function. Inner function stays the same. So inner function is g of 3. And then we multiply it by, what will I multiply this by? The derivative of which function? The inner function. So the inner function is g of 3, and the derivative of that would be g prime of 3. That's your chain rule. Okay, so g of 3, we look at what the information that they gave us, and g of 3 is 6. So g of 3 is 6, and I'm going to have this, so f prime at 6 times, then I see, did they give me this, g prime at 3? G prime at 3 is 5. Then f prime at 6 is up here. F prime of 6 is 8 times 5, and our answer is 40. Okay. So find a sheet of paper. You'll have a few of these in your homework to practice. I want you to write down okay, here's what I want you to write down on a sheet of paper. This was an AP non-calculator question. So I want you to write on a sheet of paper, f of x is equal to x squared minus 4. So write that function. Write down g of x is equal to 3x minus 2. And then write this sentence down. The derivative of f of g of x at x is equal to 3 is. And don't write any of these answers down. So just write this f of x function, write down the g of x function, and then write down the derivative of f of g of x at x is equal to 3. Okay, so derivative, we know, is dy over dx. They want the derivative at x is equal to 3. So this is the notation. So they want the derivative, dy dx, when x is equal to 3. Now, what do they want the derivative of? They want the derivative of this composite function. So what they want the derivative of is f of g of x. They want the derivative of this. The derivative of a composite function is the chain rule. The chain rule is the derivative of the outside function times the inner function multiplied by, oh, and what would I multiply that by? The derivative of what? The derivative of the inner function, g prime at x. Okay, they want x to be 3. So I'm just going to rewrite this thing now, and I'm going to put x is 3. So it would be f prime g of 3 times g prime at 3. Okay, so let's see what they've given us and what we could figure out. So g of 3, I could figure out. Here's my g function. I could figure out what g of 3 is. So g of 3, it's 3 times 3 minus 2. G of 3 is equal to what? 7. That's what g of 3 is, 7. Okay. So g of 3 is 7. That's going to go in my f prime function. And then I need to figure out what g prime at 3 is. Okay, so f prime of 7. In my f function, I need to find what f prime is. So my f function is f of x is equal to x squared minus 4 to the 1/2. I need to find f prime of x, right? I need to find what f prime of x is. Because then if I know what f prime of x is, I'll be able to figure out f prime at 7. So what law or rule would I use to find the derivative of f? Karis, what would I do? If I have x squared minus 4 to the 1/2 and I want the derivative of that, chain rule. So read me what it would be. Okay, let's clean this up. 2 over 2 will cancel. And let's write that radical below. So I've got x in my numerator, and then I've got this square root of x squared minus 4. That's my f prime of x. So this function here is f prime at x. And now we need to figure out what f prime at 7 is. So if I put a 7 in here, what would f prime at 7 be? So it would be 7 over 7 squared minus 4, so 49 minus 4. F prime at 7 would be 7 over square root of 45. And square root of 45, you need to reduce that radical. So what would the square root of 45 be? Anybody remember what that would be? Three root what? So remember we'd get 3, yeah, it'd be 3 root 5. So 7 over 3 root 5. Don't worry about rationalizing it, because if you look at these multiple choice options, they all have radicals in the denominator. So f prime of 7 is 7 over 3 root 5. Okay, so let's write that. Times g prime of 3. So g prime, here's my g of x function. G prime of x would be, what's the derivative of g of x? It would just be 3, so it's just a constant. So what that means is it doesn't matter what x value you put in here, the answer is going to be 3. So g prime at 3, like if I put in a 3 here, the answer is 3. Okay, so times 3. And then 3 over 3 would cancel, which would give me an answer of 7 over root 5. And on here, that was A on the test. So save these ones to practice for your derivatives exam. We'll go through all of that later. Yeah, I'll give you the breakdown of lots of chain rule on the AP exam, I find.